Hi, everyone. Thank you for coming to listen to our presentation. My name is Sean-Lee Merman. I am the technical lead at Streamline Games, and we'll be chatting about automating Unreal Engine development pipelines using TeamCity. Just a quick disclaimer before I get started. What I'm sharing with you today is what we found to work best for our needs. It's essentially an accumulation of 5 years of trial and error. So I would recommend that you take this information as an inspiration on how to build out your own pipeline rather than a how-to guide on how it should be built. Just a little bit about the Streamline Games before we deep dive into it. We provide game development services to our clients, but we also work on our own IPs. Here are a couple of portfolio pieces that we've worked on that have received some sort of pipeline support. For Balenciaga's Afterworld, we did performance testing to ensure a smooth gameplay experience on the cloud instances where the game was being hosted on. So the game was actually hosted on cloud instances and then streamed to a web browser with pixel streaming. Sniper Ghost Warrior Contracts had some minor deployment automations. We used those mainly for testing dedicated server deployments. And next up, we have Bacon Switch, which is our own IP, and it has the most extensive pipeline that we've built to date. And this is often used as a guideline for future projects. Most of our experimental pipeline features and ideas that we tried out in Bacon Switch. Next on the list, I have Industries of Titan, which is a game by Soft Games. We've helped them with a couple of features and performance optimizations, which we've also automated. And finally, we have Unbound, which was an internal Unreal Engine 4 multiplayer shooter. And that was actually the first project that we've ever done any pipeline work on. Before I get into what we've automated, I just wanted to kind of give a backstory on how we got started. When we started Unbound back in 2016, that was our first voyage into Unreal Engine. We didn't really know what we were doing at the time. We were a very young development team. We worked with a very strict Scrum format back then, and we needed to deliver a build every 2 weeks at the end of the sprint. And the building process initially was done manually by the team lead, but the process was done on our own development machines, and it took a long time. So the problem with that was we didn't test the build frequently enough because it took so long, and it rendered one of the developers useless for an extended period of time. And often some of the features that worked fine in the editor environment in Pi weren't working in the build. So that would cause us to find things that were broken the day before the sprint review, and we had to often OT to fix as much as we could. And that prompted us to figure out a better way for this, and something had to change. So CI/CD came to the rescue shortly after we started that project, in fact. In 2016, we set up our first Jenkins server. At the time, I ended up picking Jenkins because it was free and it was easy to get finance approval for it. We also just repurposed like an old development PC for it, and so we just essentially had Windows installed, put Jenkins on it, and that was essentially it. So we didn't have to get any approval from finance, which is fantastic. Yeah, it was actually really good. Jenkins is actually a fantastic tool, and I would recommend most studios to actually check it out and consider using it. It served us really well, but we threw some really ridiculous requirements at it. We had some projects that were using SVN as well as Git and Perforce all at the same time, and structuring out a pipeline for that was kind of crazy. Um, yeah, so we needed to look for a better option. How we were introduced to TeamCity was actually through our co-development with Brace Yourself Games on Industries of Titan. That was the first time I was exposed to a live TeamCity environment. Previously, I'd only kind of tested it out on internally in a very small format. I found that the interface was incredibly intuitive and seemed to be able to handle our ridiculous requirements at the time. Oh, before I forget, I'd like to just give a shout out to James Chan, who works at BYG. He's been an absolutely fantastic person when it comes to CI/CD and game development in general. I've bounced a bunch of ideas back and forth between the two of us while we were working on the project together. So we decided to evaluate TeamCity, and it took us only about a week to migrate or rebuild most of the pipeline that we've built in Jenkins, and it was significantly less buggy, which is great. And since we've now had a couple of years into actually maintaining a development pipeline, it was a lot easier to convince the heads of the studio to invest into the licenses and also the agents. Yeah. So just a couple of specs on what our internal pipeline looks like now. It's not very big. We're using Perforce for our source control, obviously TeamCity for our CI/CD. We've got a handful of build agents, and job configurations fluctuate between 50. The amount of jobs that run per day fluctuate between 50 to 100. Yeah. Now onto the juicy part. Some of the things that we automate internally are builds. Builds can be ridiculously complicated depending on all sorts of things. So, for example, some build, if you're doing a build for Steam or Windows, you might want to DRM wrap it after it's been made, or when you're deploying to it, or you signing the executable. We do all of our performance testing. All of that is automated. I'll get more into that later. We also automate our editor binary distribution through Unreal GameSync. We make use of filling the derived data cache, a shared derived data cache that we put on a shared drive. We do a lot of code convention checks, and we ensure that the code compiles on all platforms for almost every single code commit submit that we have. We verify blueprints, assets, and deployments to all of the stores. We try to automate that as much as possible when possible as well. Just because some of the processes can be a little bit daunting, figuring them out once, spending the time to automate them right there and then is often, and then forgetting about it, not having to remember how to do it, but just being able to deploy on a button press is pretty fantastic. I'll touch on the build commands a little bit. If you're not familiar with how to even automate something, the easiest way to kind of imagine how TeamCity works is to its ability to just take a command, everything runs via the command line, and run that command essentially. Essentially, when you're going into Unreal Engine and you select build package, this is the command that runs in the background. We just run it via some batch files. Yeah, I'll go over all of the arguments here. For our projects, we typically use a source version of the engine, so the run Unreal Engine tool bat file, UAT's Unreal Engine Unreal Automation tool batch file. It comes in the root folder of the engine. And so first off, we define the project that we want to look at. Then in the next argument, we can define the platforms that we'd like to build for. If you want, you can actually define multiple platforms. I found this to be particularly useful if you do end up running it. If you do end up doing the builds via a batch file on your local machine, this is pretty neat if you need to spit out builds for every single platform. Next, you define the client configuration. The client configuration here. So we like what configuration you'd like the game to be built in. So you have options of development, shipping, debug, game, and test. If you're doing a multiplayer game, you would also have to separately define a server config. Yeah, just something to keep in mind. With the build and cook command, we tell Unreal, the Unreal automation tool, that we want to cook and build the game. Build compiles the executable, and cook cooks down the content into a usable format for the platform that you're compiling it for. We use archive because it makes it easy to define the output of your build. So the final version of whatever you're going to be shipping is going to all be in one output, which makes it makes it easier to digest into the pipeline later on. The stage command is it copies the executable and the content into a staging area before later on being archived. I found this to actually be kind of useful if you want to do some sort of analysis on your builds. So, for example, we do some size analysis to see the results of the builds. Maybe if the build has gotten ridiculously big over a commit, we would know why. The pack argument zips up all of the loose files into a individual .pack file. It's literally just zipping things up. There's ways to encrypt it, but I wouldn't get into that. I'm not going to get into that now. We also use the prerequisites flag that includes the Unreal Engine's prerequisites installer. This is very useful for Windows builds. So this would ensure that, for example, of the prerequisites that are required to run the game are installed. Next up, we have the crash reporter. So if you're using like a crash reporting service like Bugsplat, you can use we would upload the debugging symbols that come from making this build to Bugsplat, and this command would actually include the bug reporter. So if the game does crash, the bug reporter is then able to send the logs up to the service. In this case, you'll have to modify your crash reporter so it actually sends it to the service to a service that you own. Compress is a pretty standard command. We use that to reduce the final build size. Would almost always recommend having this on. And I think this one's the most unique to automating things. This build machine flag is very, very useful for getting more detailed, a detailed look into like the cook times, more verbose logging and shader compile errors. It's just a lot of things usually get obscured if you just compile it without this command, and this would just make everything a lot more verbose. So if you're looking for errors, then this is the command that you'd want to have in there. You almost would want to have that in there when you're using dedicated agents, which you hopefully are if you're setting something up like TeamCity. Next, I'll get into some of the performance testing that we're automating. Here's, for example, one of the reports that we get spit up for Bacon Switch. So for Bacon Switch, we have over 200 levels that we needed to ensure that we're running at a acceptable frame rate for the Nintendo Switch. And doing that for 200 levels manually it's honestly a nut job. So we just run a TeamCity configuration that would automatically make the build, deploy to the Switch, run the test, and return the reports for us every day. And we do that via the via Epic's Gauntlet framework. It's a fantastic framework. Makes things very, very simple. And we use TeamCity's meta tags to extract information out of those reports and actually provide all of the information from the test that we have gotten in TeamCity's interface, which is really fantastic. So you're able to like see your test results over time. So if we get like a spike or a dip in a spike in frame rate, like if the frame rate time, like our frame rates drop or the frame time goes up, we could know which submit it's coming from. So that's pretty damn cool. As you can see, we have also included some screenshots and all the other information that we could possibly think of. Um, yeah, here's also like the report that you get generated from the CSV profiler. So essentially, what we do is um, we run a gauntlet script um, in our game that emulates us playing the video game. And before the level starts, we kick off the CSV profiler to start profiling anything that happens in the game. And then once the game completes or that one level completes, we stop it. And at the end of all of that, we take all of the results and generate these reports. These reports are absolutely fantastic, and they've actually helped us significantly with our performance testing efforts. Um, yeah, so there are some parts in the game, some significant events in the game where we can tag them and mark them in the CSV profiler. So things like garbage collecting, or in our case, when in Bacon Switch, when you throw one of the buns into the oven, that causes a lot of particle effects and things to happen in the game. So um, we make sure to take note of those to see if they are causing any performance issues. If you do want to get started with performance tests yourself, I would highly recommend Horror Games Gauntlet Automated Testing and Performance Metrics article. It's a really, really good place to start. They they have essentially a guide on how to get started. Some things to keep in mind is you'll want to build your game in the test configuration. That's because in the test configuration, it includes the console, the debugging console, which allows you to enable the CSV profiler, and it's almost like a shipping build, in the sense that it has very little overhead, but it has all of the tools that you need to gather performance metrics. One thing also to keep in mind, Gauntlet, from my experience, works on all platforms, and it's actually really simple to set up for consoles, because the way it works is it acts as a mediator to all of the console SDKs to essentially deploy the build, run the build, and gather the information. It's really fantastic. Next, I'll touch a little bit on Unreal Game Sync. Unreal Game Sync essentially ties everything together for us. It allows our team to just open up Unreal Game Sync and get an idea of how things are going in our game. So one thing I want to touch on that we thought that's really cool is you can actually customize the CIS tab and display anything here that you'd like. So essentially, the way that works is you host a SQLite metadata server, and you're able to drop information in there for all of the change lists. And we do that via TeamCity through just a couple of command lines to say whether or not a particular step or a package or build had failed or not. And so as you can see here, we have got all of the different platforms that we're building Bacon Switch for. And green indicates that the package has been built successfully, while red means something had failed. We also can see whether or not our code conventions pass, our code checks pass, or whether or not maybe the editor binaries failed to build, or if there's any issues with the content. Yeah, it's pretty neat. Yep. So one thing to kind of get Unreal Game Sync to work well for everyone is you can actually distribute your editor binaries through Unreal Game Sync, which is a really clean and easy way to do it. We don't have to submit the binaries with every commit that. So when you're looking at the history for your game, for example, any changes that you've made there, you won't actually see the build server actually making any submits there, because the way you do the editor binaries with Unreal Game Sync is to actually send them off to a different stream. You actually put you take all of the binaries and zip them off and put them in a separate stream. I'll get into detail on how to do that in just a sec. All right. So for that aspect in TeamCity, what we do is we actually use again the Unreal automation tool alongside the build graph, and the build graph actually that comes with the engine does most of the work for us. All we do is we define the script that we want to use, in which case it's the one that we're looking for is the build editor and tools script, under which they have a submit to Perforce for Unreal GameSync target. We provide the editor target that we want to use. So in our case, that would be BNS editor, because our whole project, our U project, is a BNS.U project. And then for the archive streams, this will depend on how you set up your Perforce. But if you follow the documentation that Epic provides, essentially what you need to do is you'll have a separate stream that does not branch out from your development stream, but all this stream does is essentially hold all of your zip binary files. So when Unreal GameSync looks for the zip file from a specific branch, this is where it will look and pull it from. And then we see the build machine argument again, very important. It does the same thing here. And the submit and P4 arguments here are required to actually make and submit, like actually push the results of this script out to Perforce. Then to kind of wrap things up, you'll have to add a Unreal GameSync INI into your build folder in the project, in which you would specify the zipped binary path, like I had mentioned before, as well as where your U project is in relation to for the U project that you're looking for. So we work in multiple streams, in which case we actually define. I'm defining here different zip binary paths for different streams here. And to make things a little bit easier for ourselves, you can also like change the status panel color of the streams. So when Unreal GameSync changes, the interface will change as well. So I think I can show that really quick. So like here you can see it's actually blue in color. So that would indicate that we're on the development stream. It's a nice visual indicator to see if the Unreal GameSync settings are actually sticking or not. Let's move back. And finally, if you've set up everything correctly, you're able to enable sync precompiled binaries. And when you do that and you sync a change list on Unreal GameSync, it will, after it's done completing the regular sync, it will then pull the zip file and unzip that all into your workspace. Yeah, I'd love to go into more details of other things that you could do. Unfortunately, the time I've been given is pretty short. So if you have more questions or you want to talk about automating pipelines or TeamCity or Unreal Engine, you can find me on Twitter. We're also hiring, so if you're interested to come work with us, please feel free to reach out. Yeah, I guess that's it for the presentation. If you have any questions, I think there's a Q&A session right after this, so I'll talk to you then. Thank you very much.